Hey everybody, this video tutorial will go over how to graph quadratics in vertex form. I also have listed here transformational form because it's going to look very familiar. Feel free at any point to pause the video. So the first thing in your guided notes here is vertex form itself, and it should look familiar. It should look exactly like what you just took a test on with transformations, just applied to a quadratic. So you know most of the things we need to know about vertex form already. That first thing we need to know is if A is positive, that means the graph opens up. And we know that. If A is positive, the parabola looks like this, and I have a minimum. If A is negative, we know that's a reflection. So if A is negative, it opens down, it flips it upside down, and we have a maximum. We also know if A is a fraction between 0 and 1, the graph looks wider because it's vertically compressed. And then last, we also know this. If A is bigger than 1, the graph looks narrower because that graph is vertically stretched. We also know the transformations of the parent function, and I think these are already written in your notes for you. We already know what all the A, H, and K, what they do to the parent function. We know A is either a reflection or a vertical stretch and compression. We know that H is a horizontal translation, opposite of what you think, right? If we see minus H, that moves it to the right. If we see a plus H, that moves it to the left. And we also know that K is a vertical translation up or down. The first thing we don't know about the parent is the vertex. And that vertex will always be H and K. This should make sense. If you remember your parent function, my parent function is centered at 0, 0. So just think about it. If I shift this parent, let's just say to the right and up. And you had a question similar to this on your test. If that shifted right and up, my translation meant I had a minus H and I had a plus K over here. So whatever H and K are will tell us our vertex. The axis of symmetry is this imaginary line through the vertex. It's not really a true line, but it's there. So if I have a quadratic, and we know now our vertex is at H comma K. This axis of symmetry goes right through that vertex, and it's the line x equals H. So the same as the x coordinate of the vertex. Property 4, the y-intercept. If you were asked for the y-intercept, we would just go to the function itself, plug in a 0 for x, and solve it. I don't know how often we'll be asked for this y-intercept. The domain is the same as the parent function, negative infinity to infinity, and the range is going to depend if it opens up or down. If the quadratic opens up, and there's my vertex at h comma k, that means the lowest point of that range, the lowest y value is k. So k, notice k with a bracket. And the highest it goes is that arrow, which means it's going to infinity. If it's negative, if a is negative, that means the quadratic opened down. And my vertex now is a maximum. So the lowest y value now is negative infinity, and the highest y value now is k. Let's look at some examples of these properties. I'm going to go ahead and do example 1, and I'll pause the video for you to try example 2. I'm going to go ahead actually also and write vertex form above the first example. So here is actual vertex form. So let's see if I can figure some properties out about this specific example, x plus 4 squared minus 1. So the first question I'm asked, does it open up or down? This one opens up because a is positive. All right, there's no number in front there. A is actually 1, so it opens up. My transformations, the plus 4 is a transformation. That plus 4 tells me I have a horizontal translation left 4. And then the minus 1 says I have a vertical translation down 1. My vertex, that's what's new to us here. So in general, the vertex is h comma k. So let's think about that for a second. So here I see I have minus h in my form, and then I have a plus 4 in my example. Well, how did that minus become a plus? Well, that minus became a plus because it was minus negative 4. So h itself, so my h is going to be negative 4. So my vertex here, h is negative 4. And k would be a plus, but I see a minus, so that means k is negative 1. My axis, or let me talk about this a little bit more. That should make sense. My parent function, if my parent function vertex is at 0, 0, and I went left 4, that means I went negative 4 to the left, and down 1 means negative 1 down. So my new vertex is at negative 1, negative 4. Should make sense. Always think opposite with anything with x here. My axis of symmetry, if you know the vertex, the axis of symmetry will always come from h. So here, x equals h for us is x equals negative 4. My domain, negative infinity to infinity. And my range, I didn't ask you to graph it, but remember, this opens up. We said it opened up. And we said the vertex was negative 4, negative 1. That means the lowest y value is negative 1. And those arrows point up forever to infinity. Go ahead, pause the video and try example 2. And when you press play, I'll reveal the answer. So here are my answers to the second example. Hopefully you had a chance to do them and you pause the video. The second one opens up because A is positive. That 1/2 is a vertical compression by a factor of 1/2, so the graph appears wider. The plus 2 with X is a horizontal translation left 2. Remember, opposite always what you think with X. And the minus 2 on the end is a vertical translation down 2. That left 2 and down 2 means the vertex is negative 2, negative 2. The axis of symmetry is always the same as this x coordinate of the vertex. That's at x equals negative 2. The domain is negative infinity to infinity. And the range, this one again opens up. So that vertex is a minimum. So the lowest y value is negative 2. And the arrows point up forever to infinity. Let's look at graphing these. And you can graph with the transformations if you want. I'm going to show you a different way that we're going to use with every form of a quadratic. So you'll see this Friday in the standard form video as well. So we're going to always start by finding and plotting the vertex. Then we'll make a table around that vertex because of symmetry. Then we'll plot the points in the table and sketch the axis of symmetry. And we'll connect the points with a smooth parabola. All right, so I'm going to graph this first one. It's the same one we just did. And we said the vertex here was negative 4, negative 1. So I'm going to go ahead and put that in the middle of my table. And then I'm going to pick some x's on either side of the vertex. So on the left side of the vertex, a little bit smaller than negative 4 is negative 5. Let me go ahead and plot the vertex too. Negative 4, negative 1's right here. So I'm going to pick some more x values. So I'm going to pick negative 5 and negative 6 in my table. And I'm also going to pick on the other side negative 3 and negative 2. So let's see what happens. So if I want to find the y value when x is negative 5, I'm going to plug it into my function here for x. So if I plug a negative 5 in for x, I'm going to do negative 5 plus 4 because that's parentheses. That's negative 1. Negative 1 squared is 1. 1 minus 1 is 0. So negative 5 zeros on this graph. Now think about what we know about symmetry. This graph is going to be symmetric around this vertex. So if there's a point at negative 5, 0, there's got to be a point at negative 3, 0. Let me plug in my next x value, negative 6. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. 4 minus 1 is 3. So I'm going to have a point at negative 6, 3. That means I'm also going to have a point, so it's 2 away on the left side of the axis. That means I'm going to have a point here at negative 2, 3 as well, because of symmetry. And I'll connect them. And again, this axis of symmetry was the line x equals negative 4. Go ahead, pause the video again and try that number 2 on your own. And when you press play, I will reveal the answer. All right, here's my answer, my graph for that second problem we did above. The vertex, I'll kind of go through it. I started here with the vertex. The vertex is h and k, so we already saw that above. That's negative 2, negative 2, plotted right here in red. Now keep in mind, I have this axis of symmetry, meaning whatever's on the left side is going to look the same as the right side. So I kind of built this from the left side and then transposed to the right side. So the first x I plugged in was negative 3. If I plug negative 3 into this function for x, I got negative 3 plus 2 is negative 1. Negative 1 squared is 1. 1 times 1/2 is 1/2, or 0.5. 0.5 minus 2 is negative 1/2. So that's where this point right here came from. Then I knew because of symmetry, if there was a point here at negative 3, negative 1.5, there's going to be a buddy point over here, a symmetric point at negative 1, 1.5. Oh, sorry, that should be a negative 1.5. Let me fix that. And then I did the same thing with negative 4. I plugged in negative 4 to the original function for x. Negative 4 plus 2 is negative 2. Negative 2 squared is positive 4. 4 times 1/2 is 2. And 2 minus 2 is 0. So I knew there was a point at negative 4, 0. That meant because of symmetry, it's going to have a buddy on the other side, the same distance, at 0, 0. So hopefully this helps you graph vertex form. The homework is a worksheet where the first 4 problems are just going through the properties, and then the last 4, I believe, are graphing. So good luck with the homework.